Hello again. So here we are solving this problem in which we have three situations for a block attached to a spring. The position labeled 0 meters shows the unstrained position or the equilibrium position of the spring. The block is moved from an initial position x0, which is not the equilibrium position, to a final position x final, xf, and the magnitude of the displacement is given by us. So the displacement is basically the final minus initial position. So they told us the spring constant is 46, and we want to use the data and the drawing to find the total work done in each situation. Okay, and we want the total work done by the restoring force or the tension in this spring. For each situation, first of all, we can start with the general formula. The work done in stretching a spring is equal to half k x0 squared minus x final squared. Okay, we have k, and we have the values of x0 and x final. If we substitute for the first situation, here x0 we can see that it is 1 and x final is 3. If we solve this, we will get minus 1.84 times 10 power 2 joules. So you can see that the work done here is negative, which means that the work is resistive. When we are stretching a spring, the work is resistive, it will be negative. In part B, we are stretching the spring from minus 3 meters to plus 1 meters. Now pay attention, if we are starting from minus 3 meters, this means that the spring was originally compressed. I am stretching it back to the equilibrium position and a bit further towards the plus 1 meters position. Now pay attention to something. When the spring is compressed and is being released to the equilibrium position, all the work done in this region is going to be positive because compression gives us a positive work. And then from 0 onwards, we will have negative work. Now the total work, we can find it using the conventional formula, and we can see whether it's going to be resistive or motive according to the sign that we will have. So we are starting with minus 3 squared, which is 3 squared itself, minus 1 squared. And if we calculate this, we actually get a positive value, which means that the work done here is motive. Okay, now part C, we also substitute the values of x0 and x final. This gives us, sorry, this is 46. This gives us a total work of 0 because in situation 3 we are moving from minus 3 meters to plus 3 meters. Now the spring, while moving from minus 3 to 0, is doing a motive positive work, and then from 0 to plus 3 it's doing a resistive work. So these two, when we add them up, they give us a net work of 0 joules.